what are some of the major things other than design and morality that the general theory of evolution cannot account for?
Well, I think that its explanatory mechanisms are heretofore inadequate. Random mutation and natural selection operate so slowly that it doesn't seem that this much biological complexity could have evolved on Earth in some 4.8 billion years. Indeed, John Barrow and Frank Tipler, in their book, The Anthropic Cosmological Principle, list 10 steps in the course of human evolution, like the origin of photosynthesis, the origin of an inner skeleton, the origin of mitochondria, 10 steps in the course of human evolution, each of which is so improbable that before it would have occurred or evolved, the sun would have ceased to be a main sequence star. It would have gone through the entire course of stellar evolution and incinerated the Earth. So the explanatory mechanisms of current evolutionary biology seem to be inadequate to account for the biological complexity we see given the available time.
Bill, let me ask you a question about that too. I know you're investigating this whole empirical atom question right now. You actually spoke at an event at ETS, and I happened to be in the room and asked a question regarding theistic evolution. And my question was this, and I'd love to have you answer this as well. My question to the theistic evolutionists was, what evidence do you see for theistic or just for macroevolution of any kind that could not equally be interpreted as evidence for a common designer or common creator?
Yeah.
How would you answer that question?
I would say that the best evidence that the theistic evolutionists could offer would be features in the genome or the body plan of an organism which seem to be non-functional and seem to be evolved from a common ancestor in which those genes were functional. So let me give one of the examples that Michael Behe gives. The olfactory genes that we and chimpanzees both have, a sense of smell, are called pseudogenes. They're broken. They don't work anymore. And yet and chimps have them. Why? Well, the best explanation seems to be that we got them from our last common ancestor who had these, and that therefore we both share these kind of genes, even though they don't do any good at all in our genome. To deny this, the creationist would have to say, well, God has chosen to design independently two organisms, chimps and humans, both with these broken parts in them that serve no good. It would be like saying that Ford and GM both designed independently a car with the same broken door handle in it. So I find that to be the most persuasive argument for thinking that the thesis of common ancestry is at least in part true.
But then you would need a mechanism to give you common ancestry, and therein lies the problem.
Yeah.
Right. The question would be, is random mutation and natural selection enough to generate these biologically complex organisms from these common ancestors? So there are two separate issues here, Frank, that need to be kept distinct. One is what the thesis of common ancestry. Do we, in fact, have common ancestry with other animals? And that's the least objectionable thesis of theistic evolution. People like Michael Behe are quite ready to accept. Other question is, are the explanatory mechanisms posited by evolutionary theory, like random mutation and natural selection, adequate to explain the evolution of biological complexity? And that, I think, is a much more difficult issue.
Yes, and I remember Stephen Meyer answering the question because he was on the panel too. After one gentleman of the theistic evolution sort gave the sort of answer you gave, Stephen said, well, we've been investigating some of those broken genes and we've discovered we don't think they're really broken. So obviously you'd have to do that on a case-by-case basis. Who knows what the right answer is? But this seems to change every 10 minutes, it seems.
Yeah, and you're exactly right. This is what would need to be investigated. For example, the misnomer of junk DNA.
Exactly, yes.
Now the non-coding regions of the genome is vital in regulatory function. So you're right. One mustn't jump to conclusions in this regard.